Hello my dear friends, welcome back to Reshma's Real Maths Academy YouTube channel. So today we are going to discuss the new topic parametric differentiation. See the term parametric differentiation. So in this type of method, usually what will be evident? A parameter will be there. So we look how it comes. Here the usual variables say x and y depends on a third variable, say theta or t. This theta or t is known as parameter. So here in this type of questions, x will be a function of theta or sometimes x will be a function of t. Similarly, y also will be a function of theta or a function of t. That is, if x is a function of theta, y also will be a function of theta. That is, x equal to f of theta, y equal to g of theta. If x is a function of t, y also will be a function of t. Clear? Now, we'll see how we find the differential in case of such type of questions. Before that, this type of functions which depends on a parameter are known as parametric functions. That is, x and y, they depends on another third variable, isn't it? And that third variable is known as parameter. So the functions which depends on this parameter are known as parametric functions. So now we need to know how we'll find the differential in case of parametric functions. Okay, there is an easy formula. We'll check it out. In this type of cases, the formula used is, usually the question will be to find dy by dx. What is dy by dx? Differentiate y with respect to x. And here we know that x as well as y are functions of either theta or t. Here we will consider that x and y are functions of theta in order to derive the formula. Okay, so dy by dx equal to, see, dy by d theta. So first you have to differentiate y with respect to theta, the whole divided by dx by d theta. Understood? That is, in order to find the differential or derivative of y with respect to x, first you have to differentiate y with respect to theta and then the whole divided by differential of x with respect to theta. So this is a very important formula. You have to note it down. Dy by dx is equal to dy by d theta divided by dx by d theta. So this will be clear when we do some more problems. Okay, so we'll move on to the examples of parametric differentiation. Okay, so let us do a question. Find dy by dx if x equal to a cos theta, y equal to a sin theta. Just look at the question. Here we are asked to find dy by dx. But can we find it directly? No, we have to apply parametric differentiation, isn't it? Why is it so? Because x is given in terms of theta as well as y is also given in terms of theta. So look the question here, x as well as y depends on the third variable theta. So in such type of questions, we have to apply the formula which I mentioned earlier. Clear? So first what we have to do? First we have to differentiate y with respect to theta. That is dy by d theta. Okay, see, y equal to a sin theta. Here a is a constant. So when we differentiate, a remains as such. Then what is the differential of sin theta? We have studied it. What is the differential of sin theta? It is cos theta. So dy by d theta is a cos theta. Clear? Now what we have to find? We have to find dx by d theta. So always in such type of questions, first you have to find the derivative of y with respect to the third variable, then the derivative of x with respect to the third variable, and then find out dy by dx. So now look, dx by d theta. What is dx by d theta? A. Here also a is the constant, so it remains as such. Now, next is cos theta. What is the derivative of cos theta? Minus sin theta, isn't it? So we have to put the minus sign here and then sin theta. Understood? That is dy by d theta equal to a cos theta and dx by d theta equal to minus a sin theta. Now what we have to find out? We have to find out dy by dx. What was the formula? I taught just now, isn't it? What was the formula? It was dy by d theta divided by dx by d theta, isn't it? What is dy by d theta? It is a cos theta divided by, what is dx by d theta? Minus a sin theta. Now look here, we can find an a in the numerator as well as in the denominator. So the common term gets cancelled. Now what remains? A negative sign remains and cos theta by sin theta remains. What is cos theta by sin theta? It is cot theta. So what is the answer? Dy by dx equal to minus cot theta. Understood? So this is the method to be used when x and y are given in terms of a third variable. And this method is known as parametric differentiation method because here these variables depends on a third variable, say theta. Clear? Now we can move on to the next question, isn't it? Now let us move on to the second question. See, find dy by dx if x equal to tan theta, y equal to sec theta. So this is clearly a question of parametric differentiation, isn't it? So we can do the answer. First we can find dy by d theta. What is dy by d theta? We have to differentiate sec theta with respect to theta. What is the derivative of sec theta? It is sec theta tan theta. So dy by d theta equal to sec theta tan theta. Next, what is the derivative of x with respect to theta? That is derivative of tan theta with respect to theta. What is it? It is sec square theta. Now what we have been asked to find? Dy by dx. So dy by dx. What is the formula? It is equal to dy by d theta divided by dx by d theta, isn't it? So we have already solved the numerator and denominator. We have to now substitute it. What is dy by d theta? It is sec theta tan theta divided by, what is dx by d theta? It is sec square theta. Now look here, you have a sec theta in the numerator and a sec square theta in the denominator. So we can cancel out one sec theta from numerator as well as denominator, isn't it? So what will remain? Tan theta by sec theta. We can solve this further, isn't it? How? What is tan theta? Tan theta is sin theta by cos theta. And what is sec theta? Sec theta is a reciprocal of cos theta. So we have to write it as 1 by cos theta, isn't it? Now we have a fraction in the numerator as well as a fraction in the denominator. So on solving, what we will get? We have to write the fraction in the numerator as such and we have to write the reciprocal of the fraction in the denominator, isn't it? What is it? Equal to cos theta by 1. See, this cos theta as well as this cos theta we can cancel out. And what is the answer? Answer is sin theta. So what is dy by dx? It is sin theta. Clear? Now let's move on to the third question. Find dy by dx if x equal to cos 3 theta plus 3 cos theta and y is equal to sin 3 theta plus 3 sin theta. Now we have already done 2 questions. So you must have been familiar with the method, isn't it? So just try this question by yourself. At the same time, I'll do the answer here. So if you haven't understood the method even now, then just listen carefully and understand the method, okay? Because this question is a very important question. This is also a previous question which was asked for one of the previous board exam. So you have to study this thoroughly. Now, we were using parametric differentiation, isn't it? So what is the formula? Dy by dx is equal to dy by d theta by dx by d theta, isn't it? This is our formula to be used in the question. So first we have to find dy by d theta, then we have to find dx by d theta and then divide in order to get the answer dy by dx. So in this question, before moving on to this method, we have to know some trigonometric formulas also. You have studied these formulas very thoroughly in the chapter Trigonometry of Standard 11th, but I'll just recall it for you. Sometimes you must have forgot it, isn't it? So I'll just first recall those formulas which are required for this question and then we'll move on to parametric differentiation method. Okay. Now, let me make you remember these 2 trigonometric formulas before solving this question. Actually, trigonometric formulas which you have studied in class 11 will be very useful while solving different questions of differentiation. Here, when you look at the question, directly you won't have to apply these formulas, but on solving at a particular stage, you will reach into this form so that you will have to apply these formulas in order to proceed. That is the case of this question, but in several other questions also, trigonometric formulas will have to be used in order to solve them. So, just recall those formulas which you have already studied in class 11th. As only these 2 formulas are required for this particular question, I am writing these 2 formulas here which you have to note down into your notebook, and also just refer your previous class book in order to recall the other formulas also, because for examination it will help you a lot. This is actually a previous year question, so you have to very thoroughly understand the method of solving this question. And also now let us look at this trigonometric formulas which are used for this, question. See, sin A plus sin B, that is when you have to add 2 different sine functions, sin A plus sin B. So when the question is of this form, what is the formula? Equal to 2 sin A plus B by 2 cos A minus B by 2. That is sin A plus sin B equal to 2. First you have to multiply by 2, then sin of A plus B by 2 cos A minus B by 2. Clear? Similarly, cos A plus cos B equal to 2 cos A plus B by 2 cos A minus B by 2. In case of sine, you have first term as sine and second term as cos in the RHS. In case of cos, both terms are cos itself in the RHS. Understood? Now, we'll move on to solving this question. So, first we have to differentiate y with respect to theta, isn't it? That is dy by d theta. See, here y is sin 3 theta plus 3 sin theta. So, first we have to differentiate this term with respect to theta and then plus this term with respect to theta. So, what is the differential of sin 3 theta? Here, it is not directly sin theta, it is sin 3 theta. First of all, we have to write down. Here we have to apply the chain rule of differentiation. You have already studied it. So, what is the differential of sin? Cos 3 theta. Now, what we have to do? Here we have another function. So, we have to multiply this with the derivative of this function with respect to theta. What is the differential of 3 theta with respect to theta? It is 3, isn't it? So, this term's derivative is cos 3 theta into the differential of this term, that is 3, plus here this 3 is a constant. So, we write that 3 as such. What is the differential of sin theta? It is cos theta. Clear? Now just look here. 3 is common for first term as well as second term. So we can take the common 3 outside. No. Now what we have inside the bracket? Cos 3 theta plus here what is remaining? Cos theta. Understood? We took out this common 3 outside and we have cos 3 theta plus cos theta inside the bracket. Now, this is where we have to apply the formula which I mentioned earlier. See, now this is of the form cos A plus cos B, isn't it? Just before I mentioned the formula, what was that? Cos A plus cos B. What was it? It is equal to 2 cos A plus B by 2 cos A minus B by 2, isn't it? So, on substituting we get this 3 is to be put outside. And here we have 2, isn't it? Cos A plus B by 2 and cos A minus B by 2, isn't it? Here 3 theta is in the place of A and theta is in the place of B. So 2 cos A plus B by 2 cos A minus B by 2. What do we get on solving? 2 cos 3 theta plus theta. What it becomes? 4 theta. When you divide 4 theta by 2, what is 4 by 2? 2. So here we have cos 2 theta. And here 3 theta minus theta. Then we get 2 theta. And when you divide 2 theta by 2, you get theta. So cos theta. Isn't it? Clear? So we can number this as equation 1. So this is dy by d theta. Now similarly what we have to find out? Dx by d theta. Next we have to find dx by d theta. Look at the x. It is cos 3 theta plus 3 cos theta. So what is the derivative of cos 3 theta? It is minus sin 3 theta. Since it is 3 theta, we have to multiply with the derivative of 3 theta, isn't it? What is it? It is the chain rule of differentiation. What is the derivative of 3 theta? When we differentiate with respect to theta, it is 3 plus. See, it is 3 cos theta. Here 3 is constant. Derivative of cos theta is minus sin theta. Now look at this. Here negative as well as 3 is common for both the terms. So we take minus 3 outside. Then what remains? Sin 3 theta plus sin theta remains. Now look here. It is of the form sin A plus sin B. What is the formula? It is 2 sin A plus B by 2 cos A minus B by 2. So we can apply that formula here in order to solve this. Equal to minus 3. Now sin A plus sin B 2 sin A plus B by 2 cos A minus B by 2 equal to minus 3. 2 is written as such. Sin 3 theta plus theta 4 theta. 4 theta divided by 2. 2 theta. Cos 3 theta minus theta 2 theta. 2 theta by 2 theta. Understood? So this is the second equation. Now we have to find dy by dx. We have already found out dy by d theta equal to 3 into 2 cos 2 theta cos theta and dx by d theta equal to minus 3 2 sin 2 theta cos theta. Now what we have to find out? We have to find out dy by dx. What is the formula? Equal to dy by d theta divided by dx by d theta. So we have the answers of numerator as well as denominator, isn't it? So just we have to substitute them. What is it? Equal to 3 into 2 cos 2 theta cos theta divided by minus 3 2 sin 2 theta cos theta. Now, since the terms are being multiplied in the numerator as well as denominator, so we can cancel out the common terms. 3 is common in the numerator and denominator. 2 is common. Cos theta is common. Now, what remains? Minus cos 2 theta by sin 2 theta. Minus, what is cos 2 theta by sin 2 theta? What is it? It is cot 2 theta. So, the answer is minus cot 2 theta. This is a very important question. It is moreover a previous question. So, be thorough with the question. Study it carefully. Okay. So, we can meet in another video. Till then, bye.